Combination of resistance in parallel. Let us consider three resistors R1, R2 and R3 are connected in parallel to each other. When the resistors are connected in parallel, then the potential difference across each resistor will be V. Now, in order to explain how to find the combination of resistance in parallel, what we are going to do, I'm going to consider this information to draw a figure. So here is my figure where you can see I have an external battery of potential V is connected to the combination of the resistances. Now, as you can see, the potential difference across each resistor is V and I ampere of current is passes through the battery. Now, as you can see, R1, R2 and R3 are three resistors connected in parallel, and let the current I1, I2 and I3 is passes through the resistances respectively. As we know, the total potential difference across each resistor is equal, and sum of all the electric current passes through the circuit is given as I is equal to I1 plus I2 plus I3, because this current I is coming all the way at this point and the current is divided in three different small currents I1, I2 and I3. So we can write I is equal to I1 plus I2 plus I3, and let this is our equation number 1. V is equal to I1 R1 because the potential across each resistance is V. So V is equal to I1 R1, which implies that I1 is equal to V over R1, and let this is our equation number 2. In the same way, V is equal to I2 R2, and we will get I2 is equal to V over R2, and V is equal to I3 R3 implies that I3 is equal to V over R3. As we know, the potential across the circuit is V and I ampere of current is passes through the circuit. So we can write V is equal to IR, where R is the total resistance of the circuit. So if we simplify further, we will write I is equal to V over R, and let this is our equation number 5. Combining equation 1, 2, 3, 4 and 5, we have, I'm going to substitute the value of I1, I2, I3 and I in equation number 1, and if I do that, I will write V over R is equal to V over R1 plus V over R2 plus V over R3. Now let's take the common term, which is V, and if I do that, I will write V over R is equal to, V is common, inside the bracket I have 1 over R1 plus 1 over R2 plus 1 over R3. Now this V can be cancelled out, and if we cancel out V, we will have 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And this is the combination of resistors in parallel, and this is how we will define the combination of resistance in parallel.